Hello, my name is Jacob Coleman, and in this video, I'm going to show you how to do some simple ray tracing using COMSOL. You can see I have a simple lens set up, and I'm sending in collimated light, and it's coming to a focus. So let's get started. For new, we can select using Model Wizard, using three-dimensional space. We want to go under Optics, under Ray Optics, select Geometric Optics. Add that as a physics interface, and then for the study, we want to select ray tracing, because after all, we are tracing rays. So now we can go under that and wait for it to load. Now, for the first thing that we want to do, as a good practice, let's set up the geometry. We're going to go to the part library to import some geometry. We can do that multiple ways. The easiest way is probably right-clicking geometry, and under the parts, click on the part libraries. Under part libraries, we can select Ray Optics Module, 3D, and we want to put in a spherical lens. There's a bunch of different spherical lenses, but the simplest one, I think, the one that I'm going to use today, is the spherical convex lens here. And then I'm going to add that to geometry. And now it's going to ask us whether we want to specify the radius of curvature, center thickness, or the effective focal length, or edge thickness. And we can do any combination of that. For me personally, I'm going to specify the radius of curvature and center thickness. If you're following along, you can do the same thing, or if you want to do a different lens and you know the numbers for something else, go ahead and do that. But this is what I'm going to choose. And then we'll want to specify our radius of curvature. I'm going to do 20 millimeters. And for the center thickness, I'm going to do just 2 millimeters. And then the lens diameter, I'm going to do 10. And at the moment, it's just going to be basically the axis of the lens is going to be in the Z direction. That's fine. We can just leave that as is, but that'll be important that we remember that, basically. So now we can go ahead and build it. And now we have our lens. Next, let's specify the material. If we right-click and click Add Material, we can search. I'm just going to search for silica glass, and then we'll add that to the component. And we can right-click on it and say just Add to Component. Makes it really easy. Great. So now that we have our material and our geometry, we want to specify the optics, basically, in the physics, what's going on. So there's a bunch of different settings that we can change, but under wavelength distribution in this geometric optics menu, you can see we can either select monochromatic or polychromatic. For this simple ray tracing, I'm just going to leave it as monochromatic. However, under maximum number of secondary rays, we want to change this to 0. We aren't studying any sort of stray light or reflections, so it's important that we use this as 0. For the optical dispersion model, under material properties of exterior and unmeshed domains, we can actually change this to air, which is actually kind of cool. We can have it be pretty more realistic, right? Instead of it being a perfect vacuum and assuming the index of refraction for air is just 1, we can specify temperature even, which is kind of nice and interesting. So that's it for this menu. Under material properties, actually we don't need to change anything here either, but under material discontinuity, under rays to release, we want to change this from always to never. We don't want to release any reflected rays. Now, under ray properties, you can see this is actually where the wavelength is. If you want to change the wavelength from 660 nanometers, you can go ahead and do that, but for what I'm doing, this is totally fine. Next, for the mesh, if we actually didn't select anything, it'd be totally fine, but since I'm kind of going through and talking about what's going on, we can actually build the mesh and kind of see what COMSOL is doing a little bit under the hood. So that's kind of nice. We can even change the element size if we were going to send a lot of rays and we wanted to know exactly where the rays were ending up, we would probably want to make this finer, but this is totally good for what we're doing. Next, actually, before we move any further, actually, it's important that we release rays, because right now there aren't any rays that are coming in. So under geometric optics, we want to right click and say release from grid. Now we can specify how we want the rays to come in, how they're, where they're going to start, what the angle is going to be, and so on and so forth. For grid type, I'm going to make it cylindrical. The center location, I want it to be a little bit below. I don't want it to be exactly at the lens. So I'm going to make it 4 millimeters, or negative 0.004. For the cylinder axis direction, we want it to be in the Z direction, because the lens is in the optic axis of the lens is Z. And then next for radial distribution, this is good. The radius we actually want to be 4 millimeters, because the diameter is 10, so making it 4, that'll leave a little bit of margin. The number of radial positions, that's fine as 5. The number of angles, let's actually make this 2, because then there will only be basically one surface that we're studying. Next, for ray direction, we just want it to be the Z direction, so that's good. And that is now how we've specified our ray. It's a pretty important and very in-depth, kind of, because we're releasing rays from a certain location, and we only want there to be so many, and with a certain radius, and at a certain angle. So yeah. For the next step then, we can go under the study, under step 1, ray tracing. We can either release the rays and then stop them at a certain time, or if we click on this, we can actually specify the maximum path length, basically how long the rays will travel, like what distance. For this, I'm just going to select from 0, starting at 0, and then if you hit spacebar and then type, I'm going to do 40 millimeters is where I'm going to stop the rays. That will enable us to see basically a little bit past where the rays come to a focus, for this lens at least. For if you're doing a different lens, of course it's going to be different. So I think that's everything. Now we can go ahead and hit compute either here or here, and then COMSOL is now computing where the rays go. So now we have the rays and we see where they're going. We can actually also, you can see that there's still perspective on. So if we go under this and we click orthographic projection, we can see a little bit better and more basically relative sizes. It helps us see a little bit better, at least in my opinion. And then since this is on the XZ plane, we can select normal to that. So now we can see the rays, but it's rainbow. So if we zoom in on this point, actually before we do that, let's go ahead and under ray trajectories, we can change the color. From a color table, we can just make them all the rays black. That'll help us see them a little bit better. And if we want to zoom in on where the rays are coming to a focus, we can see, oh, they're not all coming to a focus at one point. So I think there's some spherical aberration going on, basically where, because the ray is a sphere, not a perfect, the surface isn't ideal for the rays coming and focusing light at a certain point. The rays are going to end up slightly out of focus. So actually we can't see the surface of the lens. So we can actually change that by going under ray trajectories. If we right click this and we slice the model right here, because again this is in the XZ plane, we'll click this and we only want one plane, and then we can choose the color that we want. The lens will show up. Let's make it gray. If we plot that, now we can see where the lens actually is and where the rays are coming in and interacting with the lens and then exiting. So that helps us see a little bit better what's kind of going on. Yeah, so that's kind of how we do simple ray tracing using COMSOL. A side note is that when we're doing ray diagrams like this, it's conventional that we have the rays start from the left and end up on the right. That's kind of just how it goes, because if you're doing a really complicated model with a lot of rays, it might get confusing for somebody who's trying to interpret it if you have the rays starting from the left and going to the, starting from the right and going to the left, excuse me. So yeah, this is how you do simple ray tracing using COMSOL. And you can see, again, there's some spherical aberration going on, which is pretty interesting, but that's what happens when you use a spherical lens and you don't define the parameters. And yeah, so I hope you learned something from this instructional video, and yeah, I hope you enjoyed.